All right, so as Scott mentioned, last talk of the day, I'm here to talk about Azure Service Fabric. So out of curiosity, how many of you have heard about Azure Service Fabric? Okay. How many of you have actually played with it before? Okay, good. So my name is Boris Scholl. I'm a program manager on the Service Fabric team. On the Service Fabric team, I look after like container integration going forward and the orchestration capabilities. And for that session today, it's a very short session. It's like 30 minutes, and it's really hard to describe Service Fabric within 30 minutes. I'm trying to do my best. I'm going to talk you through what is Service Fabric, and then I'm going to talk to you about Service Fabric and containers, because we have some collateral out there where we talk about Service Fabric supports containers. I'm going to talk you through what that means. And then I'm going to touch on our programming models, what you can do with Service Fabric, what kind of applications you can build. And then I'll briefly touch on the managing services. Does that sound good? All right. So we're going to position Service Fabric as our microservices platform. Just to reiterate how leading industry experts define microservices, and I go quickly over that. Basically, they define it as an autonomous service that encapsulates a scenario and usually is centered around a business scenario. It can or it should contain code plus state, meaning in a microservices world, you're not just deploying the code itself, you also want to have like the state close to your code. So for example, you have a service that depends on some data. You want to be able to update that service independently from all other services. So it basically means like everything is encapsulated into one smaller service. And the reason why it's called microservice, it's not a huge monolith where it has a lot of dependencies on others. It's actually a self-standing service that just communicates with other services across well-known interfaces like such as HTTP. Another key benefit of microservices or characteristic is it should remain consistent and available in the presence of failure. What that means is even if an instance goes down of a microservice, the application itself or the value that the application provides should still be around. So microservices is not a new concept that we invented. It's actually been there in the industry for a long time, and it's been very popular through Netflix architecture, Amazon, and Google. They all propagated microservices architectures, and we in Microsoft, we actually have been using it internally for a long time, and that was called or is called Service Fabric. So with that, Service Fabric is really a platform for building and running large-scale microservices-based applications. So what that means is basically like it's not just the application you write, but Service Fabric also takes care of like all the underlying infrastructure. For example, puts services on the machines, balances the load, and so on and so forth. So what we're trying to do with Service Fabric is really make it easy for developers who want to build microservices just to focus on the development aspect without going too much into like the infrastructure stuff. So from a perspective, it's actually a very interesting Azure service because Service Fabric is branded Microsoft Azure Service Fabric. But in fact, Azure Service Fabric runs pretty much everywhere. So obviously it runs in Azure, and we're going to have a template, an Azure Resource Manager template that allows you to spin up a cluster in Azure. But you can also run it in your private cloud. And furthermore, you could even run Service Fabric applications in other clouds, other cloud providers. That's possible. So then from a functionality perspective, as I mentioned before, it's a little bit more than just like a programming model, or it's more than just a container, right? Because Service Fabric is basically a framework, a platform that allows you to do the most important things when it comes to microservices architectures. And those things start at a lower level. It basically starts with orchestration and lifetime management. So if you think about, you have many independent services, and you want to deploy those services into a cluster, onto many machines. There needs to be something that says, okay, that service goes on that machine, or this machine is under heavy load. I need to move that service, or I need to spin up the instance of the service on another node. So the whole scheduling and orchestration is actually something that's built into Service Fabric. One layer beneath, we also take care of the infrastructure. So for example, we have what we call a Service Fabric cluster, which consists of a bunch of virtual machines. And you can think about that we ping the machines, we basically build a ring, and we ping those machines and know if the machine is still healthy, if the machine can still access load, or if the machine just died. And based on that, we actually rebalance the services. This is a tremendous work that you would usually put into like other systems because you would need to do it yourself. You would need to have a cluster manager, you would need to have an orchestration tool, you would need to have a scheduler. So Service Fabric provides all of that. In addition to microservices architecture, or what's important for microservices architectures is obviously a very rich monitoring system. Because there needs to be something that tells the system, hey, my service is under such a high load, or my machine is under such a high load, I need to balance the service, or I need to move the service on another machine. So that's also built in. Service Fabric really has this rich monitoring layer that starts on a cluster level. We monitor the services and the applications. The other aspect of a microservices architecture, if you think about it, is like it's really getting new updates out fast. That's really what it is about. You want to be able to react to customer or business requirements quickly, and you want to be able to update a service as fast as possible, get it out there without other services being impacted. So Service Fabric allows that by, you can basically update individual services. But even more, we have such a rich upgrade and rollback functionality that we actually detect during an upgrade if the new service has a problem or not. And then if the service has a problem, let's say you deployed it with a faulty configuration, we would roll it back while your version 1 of your service is still running. So all of this stuff happens at more or less like the infrastructure layer. Think about like virtual machines and orchestrator on top of it. So because Service Fabric has such great orchestration capabilities and cluster management capabilities, you can even take an existing app and put it into Service Fabric, and I'm going to show that in a second. So on top of that, Service Fabric provides like a stateless services programming model, and for ASP.NET developers or cloud services developers, that's very familiar. So writing stateless applications. But we also introduce a new model which is called a stateful service. And the stateful service keeps or makes your data highly available, and we guarantee that, or we prevent you from losing data by a so-called replication mechanism. So if you write a stateful service, what's going to happen is you have a partition just similar to data partitioning. And underneath, we work with replicas. You have a primary replica and you have secondary replicas. What's happening there is the data is stored in a primary replica on a node. If that node goes down, it basically fails over to another node that has a secondary. So now you might say, how do I know that my data is consistent? So we have an acknowledgement system that actually only confirms back if a transaction has been completed successfully. So this is a very new model which has been adopted by our internal customers quickly. So if we think about a Service Fabric cluster with microservices, on the left-hand side, this is a nice diagram. It has app 1 and app 2. And you can think about the app there as just being a container for the individual services. Now if I'm going to deploy those applications into my cluster, basically Service Fabric starts distributing the services around your cluster. It distributes services amongst your cluster based on certain criteria. So there is a very good default setting, so you didn't need to worry about it. If you want to go really crazy and say, hey, I have special requirements and I would just want to place services on one node, you can do that as well. But more importantly, what's happening is if you have a service failure. So for example, because those are virtual machines can go down for like servicing events or can go down for like some other reasons. What's happening there with Service Fabric is, and that's fairly unique, let's say the machine disappears and then Service Fabric basically moves those services onto the remaining boxes and the services still stay available. This is a fairly, if you compare it to other technologies, this is a fairly interesting concept because it really balances out your cluster. And you can even think about it like if you add machines or if you remove machines. In that case, it's just removing a machine. Service Fabric also always keeps your cluster balanced and healthy. So the first demo I'm going to show, because that's like a slide, is basically I have an existing application that I just want to take and move it into Service Fabric. And what I have here is, let's go in here, go to this drive, and go my packaging demo. Here's a simple exe, and that exe could be written in anything: Java, Node.js, C#, whatsoever. And if I execute that exe, it basically, what it does is it's just listening to a port, and if I go to the port, it just returns the machine name. That's all it does, right? But the point is, let's say I want to make that application highly available. Like, let's say you have a legacy application that you want to make highly available in a Service Fabric cluster. All you need to do here is you basically you create a so-called Service Fabric package. And in here, you have an application manifest that basically just describes your application, what it is and what kind of service. And then within that application package, you have your web server. It comes with a service manifest, which is basically the service itself. And if I open that, it will show you, it basically tells Service Fabric, hey, once you spin up an instance of that service, just launch that simple web server.exe, and it will do it. Then the other point here is all the code and the binaries that I would need for that application just live in that directory. It's packaged, and then you can just go ahead and use a PowerShell command or any other or REST calls or manage code to deploy it into Service Fabric. So now the application is deployed into Service Fabric, and what I see now is a nice tool, which is our cluster manager. And this cluster manager has this view here, which basically says, I have 2 applications and 5 nodes. That's my local development cluster. And that's important to know, that locally on that machine, I have literally the same Service Fabric version running as I would have in Azure or in any other cloud. It's not an emulator. It's literally the same, the same bits. So if I go in here, look at the applications, I have my web server type. I see my Fabric web server. And then here I can see it runs on node 1, right? And if I go back to my browser and I enter this now, this is all local, obviously. If I enter this now, I have it available. So it just returns the name. But as I mentioned before, Service Fabric makes your application highly available, even like existing ones. Let's prove that out. And I'm running on node 1. I go to the nodes folder. And in here, I'm going to say, I just want to restart that node. So I basically I provoke a machine failure. I restart that node restarted, and let's close Internet Explorer, start it again, go in here, and then my service is still available. If I now went back, that's a very preview tool, but if I went back here and I would refresh it, let's use the legacy one. This is our FAT client. So it's the same thing here, web server service. It's just a different UI. And then if I look at it, now it runs on node 2. So what I've done is I basically just package it in an existing application, put it in Service Fabric, and Service Fabric manages the entire application for me. So that's one of the very key scenarios. So the reason why I was mentioning that is, and why I think it's an important scenario is, it basically sets us up for our container integration. So right now, if you look at the Service Fabric documentation out there, we say Service Fabric supports container, and that is true because we consider an application package and a web and a Windows job being a container. Like by definition, that is correct. But the entire industry talks about containers like in terms of Docker or now on Windows with Windows containers and Hyper-V containers. So the way we're going to integrate Hyper-V containers, Windows containers, and Docker containers is basically just the same way I was just showing it to you with an existing application. Just instead of saying this is an existing application I want to run in Service Fabric, we're going to say, hey, give us a container or give us a container image, and then we basically start running it in Service Fabric. So this is really the stage 1 of the container integration. But as I mentioned before, Service Fabric has a rich programming model and supports stateless and stateful services. What we're going to do later on, over the next, until we GA, I should say, is integrate Service Fabric with containers. So that means you create a Service Fabric application and you say you want to make that Service Fabric application part of your container. So you can package it. You have a Service Fabric application in a container, and then you can basically just move it around as part of an image for that. So we're going to do this for stateless ones, which is like the state of the art today, but we're also going to support that for our stateful services. So this further down the road, you will be able to create a stateful service and say, I want to partition that service, and I want to make that service part of a container, and then we'll support it. So this is our container integration, which we're working on. So it may raise a question, which we get frequently. Hey, you're talking about orchestration, you're talking about cluster management. How should I think about Service Fabric as opposed to Mesos, as opposed to Docker Swarm, and so on and so forth? So as of now, if you look at the diagram, Azure is open. Azure supports everything, right? We even shipped our container service now. So while there are different tools out there, mainly in the Linux world right now for cluster orchestration, so for example, Mesos is a very popular one. And then on Mesos, you basically put a scheduler like Marathon or Kronos or anything like that, that basically distributes your container, Docker Swarm. Service Fabric has all of that. It's basically integrated. It provides the cluster management, and it provides the container orchestration and the scheduling. So this is how you can think about it. For now, it's very easy to differentiate. We're working on porting Service Fabric to Linux, which will come before we GA. But right now, the way I would think about it is, if you're on Windows, Service Fabric is probably the way you want to do this. If you're on Linux, go with Mesos, go with Swarm, and so on. So how many of you have looked into our container service? Azure Container Service? No, not much. OK, so just briefly, we also shipped, in Azure, we also shipped a container service, which is basically our offering that allows you to spin up a Mesos cluster with a scheduler on top of it. And the question we usually get is, where do we differentiate to Azure Service Fabric? And the answer here is, if we look at the container service, on the right-hand side, the container service just spins up your container, right? So you have a container and you have a service in there. But the services at that point, they don't know about each other. So you would need to have another thing like Zookeeper or Console for service registry, for service discovery, for service monitoring. And you would need to bring your own programming model. And this is where Service Fabric goes one step further, because Service Fabric, just in addition to that cluster and orchestration management capabilities, we add like that rich development platform on top of it by providing programming models for reliable actors, for reliable services, and both are stateful and stateless. So this is how you can think about it. If you want to have an application microservices platform that makes it really easy for you to write microservices, services that are independently updatable, so that you can basically deploy them very fast, that you have rollback, and the programming model, and you just want to focus on the development aspects of it, then Service Fabric is probably the way you want to go on Windows, because we abstract all that complexity away from you. So I already touched briefly on the programming model. So we provide a Reliable Actors API. So how many of you have worked with Orleans before? Okay, how many of you have heard about akka.net? Okay. So we also have our reliable actors, and reliable actors, for those of you who have worked with it, are basically suitable for applications with multiple independent units of state and compute. So it basically avoids concurrency issues you might run into. We offer automatic state management and turn-based concurrency, which basically means we really make sure that there is that you don't run in concurrent situations. And you can build reliable stateful and stateless objects using our actor APIs. So actor APIs are really popular in certain scenarios. So for example, gaming, like if you think about Halo, for example, is built on actors. If you think about IoT scenarios where basically an actor represents a car or an object, an IoT object. So this is where those things are really, really popular. So then we also have another programming model, which is a reliable services API. So we allow you to build stateless services using existing technologies such as ASP.NET. We'll support ASP.NET for those stateless services. And then in addition, as I mentioned, we build stateful services, which is fairly new concept because, again, as I mentioned before, we taught people, hey, you shouldn't put state on your compute because scale out scenarios and so on and so forth prevents you from dynamic scaling. But if you think about like Service Fabric, think about the cluster I showed you. Everything is self-managed. We manage the state. And the advantages you get out of a stateful service are actually it's very optimized for performance scenarios or for data consistency scenarios and so on and so forth. Then for reliable services, you can communicate with the services using a technology of your choice, like you can use HTTP, you can use WCF, and so on and so forth. So those are our programming models, very rich. So just to explain what a stateful service really is, because it's basically, if you have never dealt with state or with data partitioning in a database, it's hard to understand. So a stateful service with partitions is basically, think about a scenario that you want to build a phone book, okay? And you want to build, or you want to store the data for each last name that starts with a certain letter in one partition. The advantage of doing that, obviously, is you have a smaller unit of data, and you can direct traffic directly to that partition. So it's better from an access perspective and so on and so forth. And the way you would partition that service in Service Fabric is actually you would say, okay, I'm going to create 26 partition because my alphabet has 26 letters. So in that case, every request or every service would have a unique URL where you would basically store the data. So you would basically come in, a request comes in and says, hey, I need to submit a person with last name Scholl, so my first letter is S. I'm going to go to that partition. And the other partitions are not getting that traffic. The other thing is, now you might say, hey, I may have hot and cold spots then because I have partitions that need to serve more traffic than others, right? It's very natural. Like a last name that starts with S is more popular than a last name that starts with Y, for example. So Service Fabric actually does an automatic like load leveling. So when Service Fabric detects that certain partitions under a higher load, it actually places those partitions on other services, on other nodes. You can also report the load on those services. But how do we guarantee that there is no data loss? And the way we guarantee that is a partition consists of replicas. And you have a primary and you have multiple secondary replicas. So in general, like by default, you have 3. You have a primary and 2 secondaries. And they're placed on different machines. So when a read comes in into your primary, then Service Fabric basically keeps the transaction open until the data is successfully written to the secondaries, and then it basically reports back and says this transaction was successful. So now in case of a failure of your one node, let's say your node goes down, there is a primary, we have leader election. It basically says, okay, our primary went down, I have 2 secondaries, I make one of those secondaries the primary. Very important concept, very powerful concept. So let me show you how that works. Going back here, I have a very simple service. It's word count. Let me deploy it to Service Fabric. And then going in here. And it's just counting words, right? It's counting it, and as you can see, it adds it to a certain partition, and the partition is what is just described. It writes it to the partition, and now it's counting the words, like it keeps counting them, and so on and so forth. So in a stateless world, it would be, I still have a node that I need to enable. So in a stateless world, it would be really hard now to maintain that count of the application. Let's go back to it. So let's say now my service would go down for some reason, right? It's really hard to pick up where we basically left off. So in Service Fabric, again, I'm going to go into my Service Explorer, look at my word count, which basically has the web service as a website you've seen, and then it has the count service. If I look at the count service, I see I have a primary which runs on node 4, and I have 2 secondaries. So if I now shut down node 4 and just provoke a failure and say stop node 4, say yes, and go back here, you'll see it keeps counting, it keeps counting, it keeps counting. Now you see a slight stop, which is basically now it's failing over, and then I hope I didn't mess up too much. And then it continues counting. So I didn't lose my state. I hope that actually gets across, like the stateful service is really powerful there. Let me just go back to this one. And start that node again. Okay. So going back to the slides. Reliable. So as I mentioned before, like building microservices is really, you should really focus on writing your code. And what's really important in microservices architectures is really your application lifecycle management. Because your efforts, if you have that many moving bits and pieces and services, small services, your efforts really shift, right? You're not spending much time anymore in doing integration tests of a big monolith that consists of many, many components and DLLs. So when you change one, you need to do integration testing and figure out if the other parts of your application still behave the way they're supposed to do. Or even if you think about like database schema, if you have multiple functionalities writing to the same database, and now all of a sudden one component needs an updated database schema. So there's a lot of testing involved in that development. In a microservices world, we eliminate like that complex integration testing to a certain degree. But obviously, because you have that many moving bits and pieces, it's really about a good DevOps strategy, because you want to automate everything, right? You want to make sure that if a node goes down, it comes up again, and the services are being placed. So as I mentioned, Service Fabric has all of that built in. So it has really, really rich application lifecycle management and DevOps capabilities. So it starts with the provisioning and deployment of the services, which I mentioned before. The most important part is probably you can upgrade microservices without a loss of availability. So if you have a service running in a version v1 and you upgrade your service, you can roll out the new updated functionality while your v1 service is still running. And then, as I mentioned before, it has a rich monitoring capability, so we always know the state of your cluster, of the services of the application. And Service Fabric has self-healing functionalities where it actually jumps in and says, hey, that application on that node is not healthy, or that service on that node is not healthy. I try to restart it, or I'm gonna move it to another one. And then we also ship with a set of very effective like testing tools. So in a system like that, what you really want to provoke is like chaos, and we ship with a bunch of PowerShell scripts and tools that allow you to basically create chaos in your application, and then you see how the application behaves. So let's do the last demo, which is the upgrade one. I know I'm running out of time. You guys want to see the upgrade demo, or? Yeah. No opinion? Yeah. Okay, let's do this. So the upgrade demo is, let's go back here. Let's look at my cluster. I'm going to start up my node here just to make sure I'm back in a good state. So going in here, I have an application which is called Visual Objects, and it's a .NET application deployed to Service Fabric. And some of you may feel, it may remind you of like good old times. Let I'm going to go to my browser and then see. It's so there are a bunch of moving objects, right? Looks like an old Commodore or Atari game. And just pay attention how those objects are moving. They're just moving like the crossing and stuff like that, but they're not turning. Let's say this is a service we deployed and our customers told us, you know what, that's really awesome, but we want those things to spin, right? And someone updated the code to have those little icons spin, and now I have a new version available. And now I'm going to go ahead and basically upgrade that version, which is basically the same code, but I'm telling Service Fabric, hey, there is a new version available. So now I'm upgrading that version and running the upgrade here. And now if you continue watching, this is still the V1, right? And by the way, every single little visual object in there is an actor. It's been programmed with an actor programming model. So it stopped quickly, but as you can see, they're still moving the same way they were supposed to do. So your service is still running. It's still up and running. But now after a while the upgrade runs through Service Fabric, you should see the first ones actually start spinning. Like if you look at that red one here, it starts spinning. You see this? It's not just going straight up and down. It actually starts spinning. So now every actor or every object starts spinning. And the interesting part right now is you can see you have like objects of your version 1 because they go like from the left to the right and they bounce around. But you also have like objects, new objects that have been already upgraded, like for example the red one, or another one should come in there soon. So what that demo is supposed to do is really like show you the benefits, another big benefits of Service Fabric, and it also ties into the microservices notion. I should be able to deploy services independently, possibly with no downtime to running service, and basically get out new versions of the service. So I'm going back to the slides. So with that, I'm literally at the end because it was a half-hour presentation. Just to give you a quick example, what we have a private preview and we have a bunch of like go live customers that have been working with Service Fabric for a while. Just to give you an idea what they're doing. So one is Blinkbox. It's UK's leading video on demand service delivering TV and movie content. Obviously, they support multiple devices. What they've done is they had an IaaS or a solution running on IaaS with database-backed systems. So they basically moved to a microservices architecture using Service Fabric. They really like the agility. They like the programming model and the scalability of Service Fabric. Another scenario really is, that's an architectural diagram. The other scenario is Schneider Electric, which is one of those classic IoT scenarios. It's the same thing. They basically want to query and execute command. It's really a classic IoT scenario. But we've been hearing people saying the same thing, or our customers that have been using Service Fabric saying the same thing. It's a great platform for building resilient hyperscale microservices because it provides so many things out of the box that you would need to worry about. I mean, think about like that stateful service that I've shown before, or like IT scenarios, how much time you spend in like writing code to make that work. That's all built in. So they really like it. And again, the most common scenarios we've seen so far are really IoT scenarios, is content streaming, stream analytics. We have like e-learning solutions. We have a lot of customers who already have been using Service Fabric successfully with our preview program. With that, I know it was half an hour and I really rushed through the presentation. I hope I got the value of Service Fabric across like in some way. So if you're interested in Service Fabric, go to aka.ms/Service Fabric. You can download the Service Fabric developer SDK. We're also working on samples and tutorials. It's all on that site. And with that, I'm done. Thank you. You guys, any questions or? Sorry, say it again.
How does it handle long-running workflows? So traditionally, if you do like enterprise software, you have to suspend a transaction or keep liable on failure and then return. It's sort of like what we see with workflow and app fabric. So I suppose this and the enterprise solution in the future, that would have the same construct. So I'm just wondering, for example, like when you ran your service, if that would have faulted, those should have went into like a suspended state and resumed later on. How does it do this?
Oh, so it's really hard to hear you. So I think the question is, how does it handle long-running workflows, right, in general? So we do have, I think, 2 or 3 customers who solved the solution. I'm more than happy to follow up with you because on that one, and we can take that offline. Any other questions? All right, then, guys, enjoy your lunch. No, dinner, sorry.